This is a set of buck converters that I ordered from China, just arrived today. So these are meant to be 2 amp buck converters. As you can see, they've arrived, all 10 of them actually, on the same printed circuit board. So you've got score marks here so you can break off individual ones. So these have come, you know, like directly from the factory really. So that's quite nice. So I'm going to break one of these off and solder some wires on and see what the thing can do. I have some wires attached now. So this is the input side here. It's actually set on a little blob of white tack because it's so small it's easy to knock over on the bench, especially with these wires connected to it. So on this side I've got the output, and the output's connected to the Aneng meter here, so you can see we've got about 1.5 volts out at the moment. The input, if I just measure it, let's get the X-Tech meter around here. So the input is around 10 volts, just a little bit under 10 volts. So at the moment it's converting from 10 volt input down to a 1.5 volt output, and it's a little bit fiddly, but you can get a small screwdriver on here to adjust the output. Just get the meter in shot here as well. It's quite sensitive, but if I turn the screw here, I can get the, if I turn the screw, you can see I can go up. Let's see, so the maximum is about 9.25 volts with 10 volts input. If I turn it down the other way, so that's about 0.5 volt, so the minimum seems to be about 0.5 volt. Well, let me set this up perhaps around 5 volts. There you are, 4.999 volts. Okay. So what I could do now is put one of these power resistors on the output and see how much current it can supply. So this is a 10 ohm resistor. I've also got, I think, a 3, and I've got a 1 ohm. So we'll see how we go with that. So that's the 10 ohm in place now, and I can see from the bench power supply we're drawing about 270 milliamps. It's not particularly hot, it's staying steady at 5 volts. So that should be about half an amp with the 10 ohm on there. It's getting a little bit warm now. So that's good, supplying half an amp. So we could try the 3 ohm now. That should give us about 1.6 amps, I think. This resistor is a little bit warm to the touch, but not excessively so. So let's put the crop clips on there. I might be able to hear the fan on my power supply kicking in there. Okay, so the voltage has dipped slightly, so that's slightly, oh, is it this one? So it's slightly below 5 volts now. The resistors are getting quite warm. There's nothing very warm on the board itself, so that's good. And according to my bench power supply, it's now drawing just over an amp. Okay, so 1.6 amps. It's not bad, is it? Let's just disconnect that. So this is a 1 ohm resistor, so we can try this. So this should actually overload the buck converter, because we'll be drawing, actually try to provide 5 amps with this resistor, so that will overload it. So let's give that a go. Just clip the meter into place. So I'll just hold the wire rather than clip it into place, because this might be quite a short test. Let's see. So the voltage has dipped down to 2.5 volts. Okay. That's about 2 amps coming out of my power supply. So that's not doing it for much good. Okay. So, obviously I didn't expect it to supply the regulated voltage, but at least it hasn't caught fire or anything. I think that's pretty good. Might try something in between. I've got 2 of these. I was thinking what I might do next is if I increase the input voltage, then I can change the setting on this. Maybe if I change this down to 10 volts, then 10 volts into 5 ohms, if I put those two in parallel, will give me 2 amps. So that's the maximum rating for this. So the buck converter should be able to cope with that. So I'm going to give that a try. Let's just put the meter on the input again, the X-Tech meter, and we're getting just short of 20 volts. I've changed the input to 20 volts now. And what I'll do is I'll wind the output now up to 10 volts. There we are, 10 volts. And so if I put 2 of these 10 ohm resistors in parallel, I'll have 5 ohms, so it'll be 10 volts into 5 ohms, which should give me the full 2 amps. Okay, so I've got the meter attached to the end, so I'll just dab the wire on there. So there we are, we've got 10 volts, that should be 2 amps now. And it's drawing just over an amp from the bench power supply. You might be able to hear the fan going on the bench power supply as it's trying to cool itself down. The resistors are a little bit warm. Let's check the module. The module is quite hot now actually, so that's obviously absolutely maxing out. And the resistors are really too hot to touch now. Okay, so this small buck converter can actually sustain the full 2 amps at least at 10 volts. That makes it quite useful, and you know, because of its small size, it's going to be quite good in Internet of Things equipment, for example, where we need to drop down the voltage, and it's helpful if you can do that in an efficient way. I think these are used a lot in remote control aircraft and quadcopters now as well, because obviously there you need an efficient regulator, and you also need small size and weight. So these are pretty good. I mean, especially for the money. This was only, you know, this was only £3 for 10 units, so 30 pence each, and that gets my vote.